Hello everyone. Welcome to the webinar series on Intel Higher Education Challenge 2017. In this webinar, we will discuss UART, that is Universal Asynchronous Receiver and Transmitter, which is one of the hardware serial communication protocol that is very useful for external peripheral interfacing. Here are the topics that we are going to learn today. Firstly, we will discuss what is communication and communication protocol. Then we will see the difference between serial and parallel communication. We will also go into the details of synchronous and asynchronous serial communication. And finally, we will learn about UART, how to access UART of Intel Edison, and what all are its applications. Firstly, let me ask you a question. What do you mean by communication? Communication, in a simple way, is defined as the exchange of information between one and more entity. The set of rules defined for an effective exchange of information in which both transmitter and receiver has to agree upon are called communication protocols. Data could be transferred in two ways. When whole data is transmitted in one go, for example, 8 bits of data is transmitted in one go using 8 parallel lines, then it is called as parallel communication as shown here in the figure on your right hand side. The second way is when data bits are transmitted in a sequential manner, that is, one bit after another, over a single line, which is called as serial communication. The figure on your left hand side is self-explanatory for understanding this concept. Let us now look at some of the differences between serial and parallel communication. The main difference is in the data transmission rate, which is very high in parallel communication as multiple bits are transmitted simultaneously. This type of transmission requires multiple wires for multiple bit transmission, which will increase the size, thus resulting in high cost and complexity. Whereas in serial communication, data rate is low as compared to parallel, but the form factor is small, resulting in less complexity and low cost. Because of low cost and less complexity, serial communication is widely used and is suitable for long distance communication. Let's talk more about serial communication. Serial communication is further classified into two types. One is synchronous serial communication, where sender and receiver always pairs its data lines with a common clock signal. The second one is the asynchronous communication, where data is transmitted without the use of external clock. Synchronous serial communication requires one extra wire for clock, but asynchronous communication produces internal clock for transmitter and receiver, thus avoiding the need of extra wire for clock. SPI and I2C are the most common synchronous communication interfaces. UART, which stands for Universal Asynchronous Receiver and Transmitter, is an example of asynchronous serial communication protocol. In this webinar, we will concentrate on understanding the asynchronous communication, that is UART. UART is often used for communicating with external devices. One of the applications of UART include GSM or GPRS modem for exchanging AT commands. It is also used with sensors such as accelerometers, gyroscope, GPS module, etc. It is also used to interface with wireless technologies as well, such as Bluetooth, Zigbee, RFID module, etc. Please visit the link shown in the slide for knowing more on what type of shields are supported. Let us now talk about the UART signal lines and its important configurable parameters. UART comprises of three main elements: baud rate generator, receiver line to receive data, and transmitter line for transmitting the data. For proper transmission, receiver of one device has to be connected with transmitter of the other device and transmitter of the first device to receiver of the other device. Both the devices are connected to common ground to ensure correct logic level. As UART doesn't use clock signal to ensure effective transmission of data between two devices, some rules are being defined. Both receiver and transmitter must agree upon these rules. First rule is the baud rate, which is the speed at which data is being transmitted. Baud rate is measured in bits per second. Some of the standard baud rates are 4800 bits per second, 9600 bits per second, 19200 bits per second, and so on. Out of these, 9600 bits per second baud rate is the most commonly used one. Second is synchronization bits, which are start and stop bits. The start bit is always indicated by an idle data line going from 1 to 0, while the stop bit will go back to the idle state by holding the line at 1. The third one is the parity bit. Parity bit is a low-level error checking system and it has got two variants: even parity and odd parity. And the last one are the data bits. The data bits are the actual data to be transmitted from transmitter to receiver. Length of data bits can be from 5 to 9, but usually the length is 8 bits. The figure shows the data frame of UART. The first bit is a start bit followed by data bits. The parity bit is used for error checking. The parity bit is high when number of ones in the data are odd and will be low when number of ones in the data are even. The stop bits are transmitted at the end of data frame, which implies the end of transmission. On Intel Edison board, pin number 0 or D0 is the receiver signal of UART and 1 or D1 is the transmitter signal of UART. So, to connect any peripheral with Intel Edison, the transmitter of peripheral has to be connected with receiver of Edison and receiver of peripheral has to be connected with the transmitter of Edison. To access UART of Intel Edison board using Arduino, first we should set baud rate using the API serial 1.begin function. The baud rate is given in the argument list of the function. Once baud rate is set, we can send data using the APIs. Serial1.print function or serial1.write function. Now the data is passed in the arguments. For reception of data, we can use serial1.read function. For any query, please contact us at mentor@files.in or visit our website www.files.in. Thank you and have a nice day.